Hello and welcome to another episode of the natural number game using Lean4. Today we're going to continue in the advanced proposition world and we're going to move on to level 8 and or distributed lift. So just how we know that x times y plus z is equal to x times y plus x times z. This is the distributivity of multiplication over addition. We have a similar rule, or it's like the same rule for ands and ors. In fact, or distributes over ands, and ands distributes over ors. And then right now we're going to prove one of these. So we're going to prove lemma and or distributes left. P, Q, R are all propositions. P and Q or R if and only if or like is equivalent to P or Q and P or R. Bye. Okay, let's. Sorry. Okay. Well, let's see what we're working here with. So we can intro what is this? P Q C A B C D. Intro A B. How many things we need to intro? Huh? Not just one thing that we're introducing. Okay, so here we have. Oh, okay. So I think since we have the just like an if and only, there's not one implications. We can't intro anything. So explain the cases or start applying stuff. But let's think. Bye. I guess we're gonna explain the cases. So cases H1. Okay, cases. By. Okay, constructor. Constructor maybe. Okay. Okay, so constructor lets us split up, so now I can intro stuff. Intro, let's see. Okay. P and or P or QR. And then our output should be P or Q and P or R. So P and okay, so we do let P equals and dot left P we can't do that. B implies that P. Oh wait, this is P and okay. We can do this and dot left. Okay. This is P. Is this right? And dot left. Okay, I think I'll also do just this dot left. Okay, and then let QR P and QR dot right. That gets me QR, Q or R, and P is P. Okay, this is, we're starting to make progress. And now we need to rebuild this whole mess. And now we need P or Q and P or R. Okay. Let PQ or dot INR P intro right QP Q intro left P, okay. Let PR or dot intro right RP, and then let, I think we should do exact PQ PR, oops, I need to use the right brackets, PQ PR, oops, PR, oops, intro left as well. And this is the anonymous constructor. This is the same thing as let whatever a and dot intro PQ PR. A is type P or Q and P or R. But we can also, if it's clear from context, we can just use the angle brackets instead. This is shorthand for the and dot intro. This is an anonymous constructor that uses the constructor. If an inductive type has only one constructor, like and only has one constructor, or has two constructors, and it says and you need both, or you need one of either one, so you can construct an or with either the left side or the right side. For the and, you need both the left side and the right side. So in our case, and only has one constructor, and then we can access it with the angle brackets, or has two of them, intro left and intro R. Okay, so that's like the care of our first case. I think our second case will be very similar. Let's see if we can do it a little shorter though. Okay. So now we need to prove P. Okay, so let's just intro P, Q, and PR. Okay, we have that. We want to show P and Q or R. This seems a little trickier. So P How do we get P? Yeah, if at any point you watch this video and you have any ideas, and like, while I'm trying to solve them, yeah, write a comment or write your ideas down. I'd love to see what your thoughts are while watching this. But in this case, I'm not too sure how to proceed, but I'm sure we'll figure it out. Okay, so I guess I can just split this up. Yeah, I was hoping to maybe do it in a shorter way. Let PR but I think just writing out these variables is a good way to go about it as well. Okay, so I think we just need a okay. P or R. P and QVR. So we have P or Q and P or R. And okay, so either Q is true or R is true. Why is Q or true or R is true? Yeah, I think this is the tricky thing is I need to think about the math to figure out why the math is true so I can try to turn this into the proof. Okay, so we have P or Q, or I guess, no, we just have, we have a few things. We have P or Q, P or R, and we have P or Q and P or R. And we need to prove P and Q or R. So we need to prove P, and we need to prove Q or R. How do we prove P though? Now you think about this. I realized the error of my ways. Yeah, this is impossible because I wrote down the statement wrong. There, you can't just prove that P is true here from P or Q and P and or R, because I was thinking, okay, what if in this case Q is true and R is true? Well, I can't prove P is true. But me being silly is I wrote down the wrong thing. So it should be P or Q, P and Q or R, if and only if P and Q or P and R. Wait, does our, okay. So we need to, restart this. Okay, at least all these other introduced things are useful. We need to prove P and Q or P and R. Okay, let's think. Okay, I don't know if any of this is useful, but so P and Q, or P or Q, and P and Q or P and R. So we need to prove that one or the other is true. So we'll prove this exactly with OR dot elimination. What's our OR statement that comes as input? I think Q or, yeah, Q or R, because we have P. Okay, so we have QR. I don't think we need U. Oops. I don't think we need any of you. But it's funny that I proved, okay, wait. I'm actually gonna take a brief aside. So I accidentally proved this thing. From Alex's discovery. The thing that I accidentally proved was this, but only one way. So we don't need a constructor. Oh, well, this is kind of funny. So this, by this being unimportant, simplifies to, okay, P P. So what I proved was P implies P or Q and P or R. Because you can just have P be true in all of these. Yep, that's pretty trivial. And I can also, in this case, I can actually kind of simplify this into left, right, P dot left, or dot INLP, or dot INLP. Nice. Okay, now let's get back to business. QR, and then we just put this into a couple of cases, into the two cases. The first one should be okay, so let's make this fun. Okay, so this okay. Here we need to this take some Q and proves P and Q or P and R. So we want to do or dot intro left, I think, intro left. Yeah, we have the left side, so INL and dot intro P, and then this one is Q. Okay, so this is saying, okay, with Q, given Q, because okay, Q and R is either Q or R. So given Q, prove P and Q or P and R. We only need to prove one of the sides. We're choosing the left side to prove. So or I and L, injective on the left side. So we need to prove P and Q. We have Q, we have P from earlier. We do this. Okay, and then we do the same thing with given R, or dot, I think I and R now, and dot intro PR. Nice. So this proves R implies P and Q or P and R. And that, a bit more complicated than before, is our first case. This is P and Q or R implies P and Q or P and R. Now we're moving on to our second case. Okay, so this is actually our intro. This is P and R or P and Q. I guess PQ, P and Q, P and R. Whatever, I'll do that. Sure. So this is with an or, this is with an and, so this is with an or. We can't just take the left side or take the right side from this because only one that can be true at a time. We'll probably do in proof brackets on or. Yeah. Okay, now what's our goal? What's our goal? Our goal is P and Q or R. I think we're going to want to do another or elim on this monstrosity. Okay, so here we need to prove given P and Q, prove P and Q or R. Great, great, great. Okay, so here we have fun. Given PQ, is that too many? Okay, PQ. Can we do this? Let P equals PQ dot left. Let Q equal PQ dot right. Nice. Our goal is to prove I don't know if we can have all these lets and here's. I guess I'll just put a sorry. Okay, no, that's actually fine. Cool. P and Q or R. Okay, so this is exact, or maybe we could just do it. And dot intro P or, okay, so, oh, nice. Now we just need Q and Q or R. We have Q, so that's or dot INL Q. Heck yeah. Okay. We can obviously simplify this to PQ dot left, PQ dot right. These are no longer used. now we have P and R, PR, and intro PR dot left. Now I want Q or R. We have R, so OR dot INR, PR dot right. Wow, okay. So with that pretty big proof, we have and or distribute on the left side. That was definitely quite involved, but I don't know. That was very insightful. I learned a lot, and my mistake led me to this interesting discovery. So yeah, I guess recapping all of this, constructor when we see if and only if in our goal state, and then we just deal it with one case at a time. And then here there's a lot of manipulation with using both ors and ands and dealing with the different cases. So splitting things up, putting them together. And yeah, cool things were being built and cool proofs were made. So yeah, this episode we just did one level, but it was a pretty hard level, and happy you solved it. Thank you so much for watching, and yeah, check out our next video.